Good day, 6th grade Earth Science. Today is video lecture, episode 3. So we're still in chapter 15, section 1, dealing with the atmosphere. Last time we were together, we got up to, I believe it was slide 29, talking about the lower layers of the atmosphere. So let's continue moving on in our discussion and discuss a little bit more about the upper layers, the higher layers above where we're not normally at. Now, beyond the stratosphere are the mesosphere, the thermosphere, and the exosphere. These three spheres make up what's called the upper layers of the atmosphere. The mesosphere itself extends from the bottom of the stratosphere to about 85 kilometers above the Earth. Now, if you've ever seen a shooting star, you might have actually witnessed a meteor, and that meteor was actually in the mesosphere. Okay, now let's talk about the next one moving up in the upper layers, and that's the thermosphere. The thermosphere is named for its high temperature, so hence the reason they call it the thermosphere. This layer within the atmosphere is the thickest atmospheric layer and is found between 85 kilometers and 500 kilometers above Earth's surface. So now we've talked about the mesosphere briefly and now into the thermosphere. Alright, so let's continue on. Now, within the mesosphere and the thermosphere is a layer of electrically charged particles, which are called the ionosphere. Okay, so this is within still the upper layers of the atmosphere. Now, for example, if you were to live in New Jersey and listen to the radio at night, you might actually be able to pick up a station from Boise, Idaho. You might think, well, how's that possible? Well, the ionosphere allows radio waves to travel across the country to another city. And that would normally be seen in figure 5 in your textbook. I might try to see if I can get a picture. But that's still pretty crazy to think about, literally living in New Jersey and picking up a radio signal from a place in Idaho. That's crazy. Now, during the day, energy from the sun interacts with the particles in the ionosphere, causing them to absorb AM radio frequencies. And as a result of absorbing it, then at night, when there's less solar energy, the AM radio transmissions reflect off the ionosphere, allowing those radio transmissions to be received at greater distances, which is pretty cool. So absorbed during the day, and when that goes away due to the solar energy, it's then reflected and sent back, and so people are able to listen to it at greater distance away, which is just, I think, is pretty cool. Now, the space shuttle, which you guys might be familiar with, you've heard of, it orbits Earth in the exosphere. Now, in contrast to the troposphere, the layer you live in, the exosphere has so few molecules that the wings of the shuttle are actually useless. In fact, they're actually more used for when it comes back to Earth. In the exosphere, the spacecraft relies on bursts from small rocket thrusters to move it around. Beyond the exosphere is a place we refer to as outer space. Now, let's just now we're going to get into what's called atmospheric pressure, and I think a good analogy will help understand this. Imagine you're a football player running with the ball. 6 players tackle you and pile one on top of the other. Okay? Who feels the weight more? You or the player on top? Think about that for a moment. Which I'm sure you could come to an obvious conclusion. Obviously you at the bottom, because now you have 6 other players on top of you. Well, like that, molecules anywhere else, atmospheric gases have mass. All right? Atmospheric gas extends hundreds of kilometers above Earth's surface. Just want to remind you of that. Now, as Earth's gravity pulls the gases towards its surface, the weight of these gases presses down on the air below. And as a result, the molecules nearer to Earth's surface are closer together, which means the pressure is increasing. This dense air exerts more force than the less dense air near the top of the atmosphere. Force exerted on an area, of course, is known as pressure. And if you look on slide 43, I posted a picture that gave the equation, and it says, it's the right-hand picture, which says pressure equals force divided by area, and that's known as, like I said, force exerted on area is known as pressure. Okay, now pressure, I'm sure we've heard that term before, but like I said, we're referring to a specific type, talking about the pressure within the atmosphere. Okay, now like the pile of football players, air pressure is greater near Earth's surface and decreases higher in the atmosphere. Now there was a figure, I believe it was figure 7 on page 438. I'll see if I can try to get that picture because it may be helpful with this. Please let me know if you need it directly and I can send it sooner than later. Alright, let's move on to slide 45. We're going to actually do just one extra slide today. Now, people generally find it difficult to breathe in high mountains because fewer molecules of air exist there. Jets that fly in the stratosphere must maintain pressurized cabins so that people can breathe. So now if you've ever wondered why, when you've flown in an airplane, why it has to be a pressurized cabin, it's doing so people can breathe. So it's doing it so you can breathe during that flight. Can you imagine having an hour and a half or 2 hour flight and not being able to breathe? That would be pretty scary. Well, This is where we're going to leave off on atmospheric pressure. We'll get into we'll probably touch on this a little bit more, but I believe what we're going to be moving into next tomorrow, we'll be talking about the temperature in the atmospheric layers. If you have any questions, feel free to leave them in the comments below. Reach out to me via email or Google messaging, and have a nice day.